Before we plunge into the assertion, it is vital to comprehend what molecule gas pedals are. The Tremendous Hadron Collider, LHC, worked by CERN, is a 17M ring of superconducting magnets. It is the world's biggest and most impressive molecule smasher. It represents the pinnacle of human logical accomplishment. In fact, it's strong to the point that it can reproduce the states of the universe's most memorable moments. Yet, might this machine one day hold the key to unlocking the secrets of the universe, or could it hold the way to something significantly greater? Founded in 1954, CERN is one of the world's most popular research associations, with 23 member states and endless researchers. It serves as a center for cooperation and development. The LHC is CERN's central project, but it's just one part of a huge network of molecule gas pedals and trials. Picture a course, not for vehicles or individuals, but for subatomic particles in a trial of skill, constancy, and even space itself. The LHC speeds up protons to almost the speed of light, sending them on an impact course that imitates the energy of the universe right at the moment of the Big Bang. The impacts of these crashes produce temperatures commonly hotter than the center of the sun. A variety of magnets directs the protons on their journey, while complex cooling systems keep the magnets colder than space. Inside the LHC, the beams are made to crash at 4 points around the gas pedal ring, corresponding to 4 molecule detectors: Atlas, CMS, ALICE, and LHCb. Every detector fills a unique purpose, investigating various parts of molecule physics. Together they act as gigantic cameras, capturing images of these crashes. Scientists then sift through the debris, searching for indications of the elusive Higgs boson, otherwise known as the God particle, and other anomalies that offer hints about the universe's building blocks. By focusing on the microcosm, we gain insights into the universe. However, with every answer comes another question, and with every discovery, new tests emerge. The LHC isn't just a scientific instrument. It is an exhibition of human curiosity and progress. It embodies our passionate mission to figure out the universe and uncover the key forces that shape it. However, as we push the limits of what we know, we must also consider the bigger existential questions that arise. What are the dangers of diving into the unknown? Might our pursuit of knowledge unexpectedly open up powers we have no control over? In the sacred halls of CERN, where the limits of human comprehension are continually stretched, a discovery has arisen that sends chills down the spine of even the most prepared scientists. Brian Cox, a former scientist at CERN and a prominent voice in the field of molecule physics, has recently made a statement that has captivated and unsettled the world. Cox's words resonate with chilling clarity. The goal of CERN's Large Hadron Collider is to replicate a miniature Big Bang. Yes, you heard that right, a little version of the very event that birthed our universe. Cox also explained the consequences of this goal, emphasizing the LHC's extraordinary potential to make new discoveries, including unlocking the mysteries of the Higgs boson and exploring dark matter, a mysterious substance that is a major part of the universe. Imagine harnessing the power of creation, the ability to summon the very essence of the universe. It's an enticing possibility, but one full of risk. The miniature Big Bang isn't a hypothetical concept. It's a tangible reality. Inside the LHC, the temperatures, pressures, and raw energy mimic the conditions at the universe's birth. It's like standing at the very beginning of recorded history, witnessing the birth of existence itself. However, with such power comes responsibility, and the question looms: what if something goes wrong? In fact, something did go wrong back in 1978. Russian physicist Anat Borsky experienced an accident that would forever change the course of his life. While working on the U-70 synchrotron at the Institute for High-Energy Physics in Russia, a discharge failure caused a proton beam to go directly through his skull. The beam, with a force that defies imagination, entered the back of his head and exited through his nose. Borsky's experience was extreme. He saw a flash brighter than 1,000 suns but had no immediate concerns. The beam's path caused severe damage, burning tissue and bone, but Borsky remained conscious and even walked to the clinic for treatment. The outcome was both disturbing and remarkable. The beam's path caused localized tissue damage, leading to hearing loss in one ear and partial facial paralysis. Remarkably, however, his mental faculties remained intact, and he continued his scientific career. This incident is not a singular tragedy. It serves as a reminder of the enormous power and potential risks of molecule gas pedals. The risks of an atom smasher like the LHC are not to be taken lightly. The possibility of frightening reactions and alterations to the very fabric of existence are genuine concerns, voiced by several respected experts. One of the most unsettling and fascinating concerns related to the LHC's experiments is the possibility of creating a small black hole. Black holes are regions of spacetime where gravity is so intense that not even light can escape. They are massive vacuum cleaners, devourers of stars, mysterious entities lurking in the shadows of the universe. The fact that the LHC could potentially create such an entity, even on a small scale, is staggering to both conservative and radical scientists alike. Might this black hole one day grow uncontrollably, consuming the Earth from within? Scientists at CERN have assured the public that any black hole created would be unstable and would dissipate rapidly. However, the distant possibility has sparked discussions, fears, and a sense of awe at the power we wield. To understand how the LHC could create a black hole, it's important to examine the basic mechanics of molecule gas pedals. When protons are smashed together at nearly the speed of light, the energy produced is so immense that it warps the fabric of spacetime itself. Imagine a trampoline stretched tight, with a heavy object dropped onto it. The fabric bends, and if the object is heavy enough, it could create a depression so deep that nearby objects are pulled into it. This analogy helps explain what could happen at the LHC. In the realm of quantum physics, where the laws of the universe are strange and wondrous, there exists a theory that additional dimensions may be hidden within our world. If these dimensions exist, the LHC's experiments could tap into them, creating a gravitational well that forms a tiny black hole. This mysterious dance of particles has even caught the attention of several prominent scientists, including the late Stephen Hawking. In his book The Grand Design, he warned of a scenario where the Higgs boson could become unstable at extremely high energy levels. This instability could lead to a catastrophic event known as vacuum decay, a disastrous occurrence that wouldn't destroy the Earth, but could potentially obliterate the entire universe. The respected British cosmologist and astrophysicist Sir Martin Rees also expressed concerns about the experiments conducted at CERN. In his book Our Final Hour, Rees examined the potential dangers of atom smasher tests. Played it safe to guarantee the security of the LHC. Truth be told, Brian Cox himself recognized the significance of these actions, perceiving the far-reaching concerns encompassing the LHC's activities. Cox stressed that there are thorough safety conventions set up. Complete surveys guarantee that the LHC's operations are led with absolute attention to detail. Cox consoled the public that the energies involved are well within the normal limits of Earth's current environment, and the possibilities of making a stable black hole are cosmically low. Regardless of whether one were made, scientists state it would be so minuscule and unstable that it would dissipate rapidly in an eruption of energy, a phenomenon predicted by Stephen Hawking known as Hawking radiation. It would be a brief snapshot of vast marvel, just a fleeting glance into the chasm before vanishing. Some have speculated further, proposing that the LHC's trials could open a doorway to another universe or dimension. While this idea is largely dismissed by mainstream scientists, it has caught the imagination of many, becoming a subject of revenue, fear, and even legend. What lies beyond our universe? Might we accidentally release forces or substances that we don't understand? The idea of opening a door to hell has even been sensationalized in various media, stirring up uncertainty. Yet how did this idea emerge, and what does it mean in terms of scientific inquiry? The concept of extradimensional spaces isn't new in physics. String theory, a leading contender for a unified theory of everything, suggests that there may be more than the usual 3 dimensions of space and one of time. These additional dimensions could be compactified, hidden from our perception but theoretically accessible or revealed under extreme circumstances. Now, imagine the LHC as a massive key, opening doors that have been sealed since the beginning of recorded history. When protons collide at energies never before achieved on Earth, They could, in theory, create waves or fluctuations that probe these hidden dimensions. If they exist, the LHC might actually uncover them. But before we get carried away with wild speculation, it's important to note that while the LHC is undeniably powerful, there is no conclusive evidence to suggest it will open a doorway to another universe, let alone to hell itself. Nonetheless, the allure of the unknown, combined with the mysterious nature of quantum physics, ensures that such ideas will continue to captivate the public imagination. So, should we be worried about the LHC and its potential risks? It's easy to be swept away by thrilling headlines and fears of global catastrophe, but the truth is that the researchers at CERN are extremely mindful of the risks involved. They have taken precautions to ensure their investigations are safe, and continue to monitor and evaluate their work with the highest level of diligence. The potential benefits of the research, advancements in our understanding of the universe, the discovery of new particles, and the study of dark matter, are truly remarkable. It's a display of human ingenuity, as well as a window into the very heart of the universe. Anyway, like any great leap forward in science, it comes with its share of dangers, and we should approach it with a balance of awe, respect, and caution. The Large Hadron Collider represents the front line of scientific inquiry, where theoretical physics meets experimental reality. Its true potential to answer fundamental questions about the universe, such as the origins of mass and the nature of dark matter, is unparalleled. However, despite rigorous safety measures and detailed calculations, the LHC still evokes a sense of mystery and fear among some. The sheer size of the machine and the energy it generates are staggering, and each new experiment paves the way for strange scientific territories. While most scientists remain confident in the safety of the LHC's experiments, there are clear uncertainties. What if new, unexpected anomalies emerge that challenge our understanding of physics and the laws of the universe? The LHC stretches the boundaries of human knowledge and tests the limits of our control over the natural world, as particle collisions replicate conditions hidden since the Big Bang. The significance of these investigations raises existential questions about the potential consequences of altering the very fabric of the universe. Nonetheless, the LHC's accomplishments in particle physics have been momentous. It has led to the discovery of the Higgs boson, advanced our understanding of the Standard Model, and opened pathways to potential breakthroughs that may one day shape our technological future. Despite the risks, the pursuit of knowledge remains one of humanity's most ambitious endeavors. The journey of scientific discovery is seldom without hazard, and the LHC is no exception. Its experimental tests delve into realms of physics where intuition no longer applies. For decades, physicists have attempted to understand the fundamental forces of nature: gravity, electromagnetism, the weak nuclear force, and the strong nuclear force, each playing a critical role in the formation of matter. The Large Hadron Collider is arguably one of the most ambitious scientific instruments ever created, serving as a monumental step forward in our quest to understand the fundamental nature of the universe. Its experiments push the boundaries of knowledge, probing domains where the very laws of physics are tested to their limits. By accelerating protons to near-light speeds and colliding them, the LHC mimics the conditions present in the early universe, mere fractions of a second after the Big Bang. This quest for knowledge, while inspiring, raises a host of questions, concerns, and philosophical implications that go beyond mere scientific curiosity. Despite the advances made in particle physics, the key question remains: what exactly is the ultimate fate of the experiments being conducted within the LHC? Although scientists have run simulations and accounted for every possible scenario, the unexpected is always a possibility. There could be a new particle interaction or discovery that defies our current understanding, pushing physics into unfamiliar realms. For instance, the detection of dark matter and dark energy could revolutionize our understanding of the universe, leading to breakthroughs we cannot yet predict. Another key aspect of the LHC's impact lies in the potential advancements that could arise from its research. Particle accelerators have long been a source of innovation, contributing to advancements in medical imaging, cancer treatment, and materials science. The LHC is no exception. Beyond its contributions to theoretical physics, it has spurred developments in computing, high-precision instrumentation, and other fields, demonstrating that scientific endeavors often have applications far beyond their immediate objectives. This aspect of the LHC underscores the far-reaching impact that cutting-edge research can have on society, driving innovation in unexpected ways. However, the LHC is not immune to scrutiny. Critics, including some prominent scientists, have raised concerns about the course of such high-stakes experiments. What if, in pursuit of answers, we accidentally unleash a phenomenon that we are ill-prepared to understand or control? Hypothetical ideas, such as quantum fluctuations or the creation of black holes, although highly unlikely, invite discussions on the responsibility inherent in wielding such immense power. These fears, however, are largely speculative, as they tap into a primal fear of the unknown, a fear of venturing too far and encountering something that cannot be undone. Fortunately, established scientists have taken a very cautious approach to mitigate risks. Experts routinely reassess the potential dangers of their experiments and are committed to rigorous safety protocols. Many of the perceived risks, such as the creation of a stable black hole, are virtually non-existent based on current observations. Nevertheless, the questions raised by the LHC's research highlight the delicate balance between progress and caution in science. While the rewards could be groundbreaking, so too could the consequences, should something unforeseen occur. As the LHC continues to operate, it serves as a reminder of the insatiable curiosity that drives humankind's quest for knowledge. Despite the uncertainties and fears surrounding its work, the desire to understand the universe remains at the heart of this global scientific endeavor. The LHC's mission, whether it leads to answers about dark matter, the Higgs boson, or even the fundamental nature of reality itself, will continue to shape our understanding of the universe and perhaps our place within it.